Neptune, the eighth planet from our Sun, is a world of mystery. This distant giant, named after the Roman god of the sea, has intrigued astronomers and space enthusiasts alike for centuries. Its discovery in 1846 was a milestone in the field of astronomy, marking the first time a planet was found through mathematical predictions rather than direct observation. It is a gas giant like Jupiter and Saturn. However, unlike its larger siblings, Neptune has unique characteristics that set it apart. Its atmosphere is composed mainly of hydrogen, helium, and methane, creating a dynamic and ever-changing environment. Neptune is known for its striking blue color. This vibrant hue is not just for show. It tells a story of the planet's atmospheric composition and the processes occurring within it. The deep blue color is a result of the absorption of red light by methane gas in the atmosphere, combined with the scattering of sunlight by the planet's clouds. This color comes from methane in its atmosphere. Methane absorbs red light and reflects blue light, giving Neptune its characteristic azure appearance. This phenomenon is similar to why Earth's sky appears blue, though the mechanisms are different. Neptune is very far away. Located about 4.5 billion kilometers from the Sun, it takes sunlight over 4 hours to reach this distant world. Its remote location makes it one of the least explored planets in our solar system. This makes it difficult to study. The vast distance poses significant challenges for spacecraft and telescopic observations. Despite these hurdles, missions like Voyager 2 have provided invaluable data, offering glimpses into Neptune's complex atmosphere and intriguing moons. Despite the challenges, scientists are fascinated by Neptune. Its dynamic weather patterns, including the fastest winds in the solar system, and its mysterious internal heat source, continue to captivate researchers. The planet's extreme conditions offer a natural laboratory for studying atmospheric physics and planetary formation. They want to learn about its atmosphere, which is home to massive storms and supersonic winds. Understanding these phenomena could provide insights into weather systems on other planets, including Earth. Its rings, which are faint and composed of dust particles and ice, and its moons. Neptune has 14 known moons, each with its own unique characteristics and mysteries. One moon in particular is of great interest: Triton. Triton is the largest of Neptune's moons and is unique because it orbits the planet in the opposite direction of Neptune's rotation, a phenomenon known as a retrograde orbit. Triton may hold clues to the origins of life. Its surface is covered with nitrogen ice and it has geysers that spew nitrogen gas, suggesting that there may be a subsurface ocean beneath its icy crust. It is a world of ice and rock, with a landscape that is both alien and fascinating. The surface features include frozen plains, rugged terrain, and cryovolcanoes that erupt with icy materials instead of molten rock, with a very thin atmosphere. Triton is very cold, with surface temperatures plunging to around -235 degrees Celsius. Despite these frigid conditions, the possibility of liquid water beneath its surface makes Triton an intriguing target for future exploration. But there may be liquid water beneath its surface. This potential subsurface ocean could harbor the conditions necessary for life, making Triton a key focus for astrobiologists and planetary scientists. The allure of Neptune and its moons continues to drive our quest for knowledge, pushing the boundaries of what we know about our solar system and the potential for life beyond Earth. Triton is a very unusual moon. Most moons orbit their planets in the same direction as the planet's rotation. Triton orbits Neptune in the opposite direction. This is called a retrograde orbit. Scientists believe that Triton may have formed elsewhere in the solar system. It was later captured by Neptune's gravity. Triton may be similar to Pluto and other dwarf planets in the Kuiper Belt. Triton has a very young surface. This suggests that it is geologically active. There may be volcanoes or geysers that erupt from its interior. These eruptions could bring materials from Triton's subsurface ocean to the surface. Scientists were excited about the possibility of sending a mission to Triton. The enthusiasm was palpable as they gathered in labs, discussing the potential discoveries that awaited them on this distant moon of Neptune. Triton, with its unique retrograde orbit and mysterious surface features, had long been a subject of fascination. The scientific community was abuzz with the possibilities of what could be learned from such an ambitious mission. The Trident mission was designed to study this intriguing moon. Named after the three-pronged spear of the sea god, the mission aimed to pierce the veil of mystery surrounding Triton. Engineers and scientists worked tirelessly on the spacecraft's design, ensuring it was equipped with the latest technology to withstand the harsh conditions of space and the moon's surface. The mission's objectives were clear: to explore Triton's geology, atmosphere, and potential for harboring life. It would have launched in 2026 and arrived at Triton in 2038. The timeline was ambitious, but the team was confident. The journey would take 12 years, a testament to the vast distances involved in space exploration. The launch would be a historic event, marking humanity's first dedicated mission to Triton. The spacecraft would travel through the solar system, using gravity assists to gain speed and adjust its trajectory. The Triton spacecraft would have carried instruments to study Triton's surface, atmosphere, and magnetic field. These instruments were meticulously designed to gather data that could reveal the moon's secrets. High-resolution cameras, spectrometers, and magnetometers were among the tools that would have been used to analyze Triton's composition and environment. The data collected would have provided invaluable insights into the moon's history and its potential for supporting life. It would have searched for signs of a subsurface ocean. Triton is believed to have a liquid water ocean beneath its icy crust, a key ingredient for life as we know it. The mission would have used advanced radar and thermal imaging to detect and map this hidden ocean. Discovering such an ocean would have profound implications for our understanding of where life might exist beyond Earth. Trident would have given us our first close-up look at Triton since Voyager 2 flew by in 1989. The Voyager 2 mission provided tantalizing glimpses of Triton, but much remained unknown. Trident promised to build on that legacy, offering detailed observations and new discoveries. The scientific community eagerly anticipated the wealth of information that would come from this mission, hoping it would answer long-standing questions and raise new ones. However, NASA decided to cancel the Trident mission. The decision was met with disappointment and frustration. Years of planning and hard work seemed to be in vain. The reasons for the cancellation were complex, involving budget constraints and shifting priorities. Despite the setback, the team remained hopeful that the mission could be revived in the future. The agency decided to fund 2 missions to Venus instead. Venus, often called Earth's twin, presents its own set of mysteries and challenges. The decision to focus on Venus was driven by the potential for new discoveries about our closest planetary neighbor. These missions aim to understand Venus's climate, geology, and potential for past habitability. While exciting, this shift in focus left many wondering about the missed opportunities on Triton. This was a disappointment to many scientists. The scientific community had high hopes for the Trident mission, seeing it as a chance to explore one of the most intriguing moons in our solar system. The cancellation felt like a step back in our quest to understand the outer planets and their moons. Many scientists voiced their concerns, advocating for the importance of exploring diverse celestial bodies. They believe that Triton is a more promising place to search for life than Venus. Triton's potential subsurface ocean and unique geological features make it a prime candidate for astrobiological studies. While Venus offers valuable insights into planetary evolution and climate, Triton holds the promise of discovering life beyond Earth. The debate continues, with many hoping that future missions will once again set their sights on this enigmatic moon. Despite the cancellation of Trident, scientists still believe that Neptune is an important target for exploration. The Trident mission was designed to study Neptune and its moon Triton, but even without it, the scientific community remains deeply interested in what Neptune can reveal. This distant planet holds many secrets that could help us understand not just our own solar system but planetary systems around other stars as well. Neptune can teach us about the formation and evolution of our solar system. By studying Neptune, scientists hope to gain insights into the processes that shaped the early solar system. This knowledge is crucial for understanding how planets form and evolve over time. Neptune's unique position and composition make it a key piece of the puzzle in our quest to comprehend the cosmos. Neptune is a gas giant, but it is different from Jupiter and Saturn. While all 3 are gas giants, Neptune and its near-twin Uranus are often referred to as ice giants because they contain more ices, such as water, ammonia, and methane, compared to Jupiter and Saturn. This distinction is important because it suggests that Neptune and Uranus formed in a different part of the solar system where these ices were more abundant. It has a higher proportion of heavier elements. This higher proportion of heavier elements, or metals in astronomical terms, indicates that Neptune's formation involved different materials and processes compared to Jupiter and Saturn. Understanding these differences can provide valuable clues about the diversity of planetary systems in our galaxy. This suggests that it formed in a different part of the solar system. The specific region where Neptune formed likely had a different mix of materials, which influenced its composition and development. By studying Neptune, scientists can learn more about the conditions in the outer regions of the solar system and how they contributed to the formation of planets. Neptune has a very dynamic atmosphere. Its atmosphere is characterized by rapid changes and extreme weather conditions. The planet's deep blue color is due to the presence of methane in its atmosphere, which absorbs red light and reflects blue light. This dynamic atmosphere is a subject of great interest to scientists studying planetary weather patterns. It has the fastest winds in the solar system. These winds can reach speeds of over 1,000 miles per hour, far surpassing the wind speeds found on any other planet in our solar system. The mechanisms driving these incredibly fast winds are still not fully understood, making Neptune a fascinating target for further study. These winds can reach speeds of over 1,000 miles per hour. The extreme wind speeds on Neptune are a testament to the planet's complex and dynamic atmosphere. Studying these winds can help scientists understand the atmospheric dynamics, not only of Neptune but also of other gas giants and exoplanets with similar conditions. Neptune also has storms like the Great Dark Spot that was observed by Voyager 2. This massive storm, similar in size to Earth, was a prominent feature when Voyager 2 flew by Neptune in 1989. Although the Great Dark Spot has since disappeared, new storms continue to appear, showcasing the ever-changing and turbulent nature of Neptune's atmosphere. These storms provide valuable data for understanding the atmospheric dynamics and weather patterns of gas giants. Section 5. The Search for Life Beyond Earth. The search for life beyond Earth is one of the most fundamental questions in science. We want to know if we are alone in the universe. There are many places in our solar system where life could exist. These places include Mars, Europa, Enceladus, and Titan. Triton is also a candidate for life. Astrobiologists are interested in places that have liquid water. Water is essential for life as we know it. Section 6. Future missions to Neptune. Although the Trident mission was cancelled, there are still hopes for future missions to Neptune. Scientists have proposed a number of concepts for future missions. One concept is for a Neptune orbiter. This spacecraft would orbit Neptune and study its atmosphere, magnetosphere, and moons. Another concept is for a Neptune lander. This spacecraft would land on Triton and study its surface and interior. A lander mission would be very challenging, however, it would also be very rewarding. Section 7. Understanding our solar system. Studying Neptune can help us to understand the formation and evolution of our solar system. The giant planets, like Neptune, played a major role in shaping the solar system. They scattered smaller objects like asteroids and comets into different orbits. Neptune's gravity also helped to stabilize the Kuiper Belt. The Kuiper Belt is a region of icy bodies beyond Neptune. It is home to Pluto and other dwarf planets. Section 8. The importance of exploration. Exploration is essential to our understanding of the universe. It allows us to ask new questions and to make new discoveries. Exploration can also inspire us and challenge us to think differently. The exploration of Neptune is just beginning. There is still much that we do not know about this distant world. Future missions will undoubtedly reveal new and exciting discoveries. Section 9. Conclusion. Mysteries yet to be solved. Neptune is a world of mystery and wonder. It is a gas giant with a dynamic atmosphere, a system of rings, and a collection of intriguing moons. One of these moons, Triton, may even harbor life. The cancellation of the Trident mission was a setback for Neptune exploration. However, it has not dampened the enthusiasm of scientists who are eager to unlock Neptune's secrets. Future missions will undoubtedly reveal new and exciting discoveries about this distant and fascinating world.